Okay, so now we would see the implementation of quicksort. So we will take this two arrays as an input, and we will try to do quicksort in Python. So we have A and we have B array. So let's implement quicksort. So we write a function which takes an array, and then the base case, if length of the array is less than 2, you return the array. Okay, if not, you need to have a pivot, which is the first element in array, and we need to have a list which is lesser than the pivot element, right? Okay, and we need to also have another list which is greater than the pivot. Okay, so once we get that, we need to add lesser. So you need to do the quicksort again because you have to recurse it. So you have to do quicksort of this array. So and then you add the pivot, and then you add the do again quicksort of this list, which is greater. Okay, so this should work. So less, we can also use equal to. Okay, so now we will try to print quicksort of A. Okay, so the error is can only concatenate list, not into list. Okay, we are adding an integer which is array of 0, so we just make this as a list, and then yes, so similarly we can do a quicksort. Yes, so this is how quicksort is implemented in Python, so you can get this. So I'll repeat what I've done here. So we passing the array for this function quicksort. In the base case for the quicksort, as we have understood, is the length of array should be less than 2. If it is less than 2, it will return the array. In the quicksort algorithm is we have a pivot, we have a lesser element and greater element than the pivot. So we have a list containing elements which are lesser than the pivot, and also we have a list which have greater than the pivot. So again we do a recursion of quicksort for lesser list and also for the greater list than the pivot, and then we are adding the lesser element plus pivot element plus greater. So that's the quicksort implementation in Python. Thanks a lot.